All right, so get ready because today we're diving deep
Deep?
into the world of chemical engineering.
Right.
But not the textbook stuff. No way.
Fire.
We're talking about those hidden heroes
Yeah,
and the innovations that kind of fly under the radar,
total.
even if they've shaped the world as we know it.
You know, it's funny how we always picture
Yeah.
top inventions as these massive
Right.
concepts, you know?
Yeah.
But when you really look at it, it's the specifics, the
Ah.
individual breakthroughs
Yeah.
that might not make the history books,
Right.
but have a huge impact.
Absolutely. I think our listeners are going to love this one.
I think so too.
We're digging into all sorts of things, lecture notes,
I love it.
cantorical articles, the good stuff,
Yeah.
to uncover those aha moments.
It's really interesting because
Yeah.
something we found while prepping for this
Wow.
is how much the definition of a groundbreaking invention
Okay.
can totally change, you know?
Intrigue. What do you mean?
Well, we have two top 10 inventions lists.
Okay.
The first is a recent survey, all chemical engineers,
All right.
and it's all those broad categories, you know, fertilizers,
Well, like-
batteries, synthetic fiber.
Like the cornerstones of modern tech, basically.
Exactly. But then we found this list from 1913.
Oh, wow.
A competition by Scientific American.
Wow.
And it's amazing. It's all specifics.
Okay.
We're talking Moissan's electric furnace, the cyanide process for gold extraction,
Wow. Yeah.
even Daimler's gasoline-powered automobile.
That is quite a contrast.
It is.
Like comparing, I don't know,
totally different.
a grocery list to a museum catalog.
Yes.
You got your staples and then these super intricate objects.
And that's where it gets good.
Okay.
Because the 1913 list, being so specific, it makes us think about the legacy. It's not just about fertilizers as a concept,
Right.
but the invention of a specific process or
Okay.
a particular furnace that changed an industry.
Right. So it's like tracing the lineage of it all.
Yeah,
Seeing how one breakthrough leads to another.
exactly.
A chain reaction.
It's about seeing a challenge
Right.
at a certain moment
Yeah.
and the ingenuity to solve it with what you have.
Yeah. And sometimes it's those small solutions that have the biggest impact.
Exactly.
Okay. So we're talking unsung heroes, right?
Yes.
Unexpected innovations
Mhm.
and that power of specificity.
Love it.
Where do we even begin?
Let's hear it.
Okay.
Let's look at the stories
Okay.
behind some of these inventions and
Yeah.
the minds behind them, and
Yeah.
get ready for a surprise because we're going all the way back
Okay.
to the 18th century
Wow. Okay.
to the world of sugar
Sugar.
production.
Okay. You have my attention. Tell me more about the hidden innovations in my sugar bowl.
Well, early sugar processing was incredibly labor-intensive, and it used a ton of energy. Plus, the quality of the sugar they produced was often, well, not great.
I bet. So how did things change?
Some brilliant chemical engineers stepped in and tackled these challenges head-on, and they did it with specific, targeted inventions. The lecture talks about the introduction of vacuum evaporation and something called the multiple effect evaporator.
Okay, now those sound like some serious technical terms. Break it down for me. What exactly did these inventions do, and how did they revolutionize the sugar industry?
Okay, so think about how you normally boil water.
Right.
It takes a lot of energy to get it to a rolling boil and evaporate, right? Now imagine trying to do that with massive quantities of sugarcane juice to get the sugar out. It's super inefficient.
Yeah, that sounds like it would take forever and a half and probably use a ton of fuel.
Mm-hmm.
So how did these inventions solve that?
Well, vacuum evaporation, like the name suggests, uses a vacuum.
Right.
What that does is it lowers the pressure, and that allows the juice to boil and evaporate at a much lower temperature. The cool thing is, it also helps preserve the delicate flavors of the sugar.
Oh, so it's like cooking something delicate on a low simmer instead of blasting it with high heat.
You got it. And then you have the multiple effect evaporator that
Yeah.
takes things even further. Instead of just letting the steam from the evaporation escape, they capture it and use it to heat the next batch of juice. It's like this chain reaction of heat efficiency.
So they found a way to recycle the heat energy. That's brilliant.
It really is. And, you know, these inventions had a huge impact.
What kind of impact are we talking about?
They completely transformed how efficient sugar production was and the quality of the sugar that was produced. And because of them, we're able to produce higher quality sugar on a much larger scale. Lou's invention, as amazing as it was,
Right.
it happened when slavery, you know,
Yeah, of course, it's the 1800s.
was a huge part of the sugar industry.
Right.
And his thing, making it more efficient,
Right.
it could mean less reliance on enslaved labor,
Oh, I see.
which some owners, they didn't like that.
Yeah, makes sense, sadly.
It's like progress isn't always a straight line.
Yeah, you're right.
Even good advancements, people resist them.
Especially when it challenges how
Exactly.
things are, the power structures.
It makes you think, right?
Yeah, it really does.
About ethics and innovation, even today.
Absolutely huge implications.
These sugar stories are fascinating.
Yeah, they are.
They show innovation can be
Right,
a force for social change, too.
Yep.
Sometimes on purpose, sometimes not.
right.
But
Right.
also, it usually comes from
Yeah.
wanting to solve a real problem.
That's a good point.
Speaking of problems,
Okay.
remember Moissan's electric arc furnace?
Oh, yeah, yeah, from the 1913 list.
That thing was huge.
Okay, but why, though? What made it so special?
So imagine
Yeah.
it's the late 1800s.
Okay.
Steel, aluminum, they're booming.
Right, makes sense.
But they're limited
Okay.
by how hot their furnaces get.
Right, you need a certain amount of heat
You got it.
to melt things.
Exactly. And that's where Moissan's like,
Okay.
I'm going to use electricity
Oh, which is...
to get crazy heat.
I like where this is going.
Way hotter than burning stuff.
Right, right.
His electric arc furnace
Okay,
used this high voltage electric arc.
okay.
And it could get to, get this,
How hot are we talking?
over 3,000 degrees Celsius.
3,000 degrees. That's really hot.
That's really hot.
So not just like a bit better.
No way!
This changed what they could even do.
Completely.
And,
Suddenly you can make
Yeah.
high-grade steel, aluminum,
Stronger, I imagine.
stronger, lighter, way more durable.
So it wasn't about more metal.
Nope.
It was about better metal.
Exactly.
Wow.
Yeah.
So this one invention,
Right.
it's like a domino effect. Totally.
On all these industries.
This is what I'm talking about.
Right, the specifics.
You solve one problem,
Right,
how to get more heat, basically,
right.
and boom, you change material science forever.
That's incredible.
It makes you wonder, right?
It really does.
What seems small now
Yeah,
could be huge later on.
absolutely. Like, we might not even realize it.
Who knows, right?
It's like you said, innovation
That's
is,
not how it happens.
it comes from anywhere.
Yeah, the tinkerers.
The ones who ask, what if?
Those are the ones.
I love that.
This has been so interesting.
Me too. It really puts things in perspective.
All these hidden stories.
And the people we never hear about.
Right. They shaped our world.
It makes you appreciate it all, you know?
Exactly.
Well, that's all we have time for on this deep dive,
That was great.
but we'll be back next time
Looking forward to it.
with even more fascinating stories
Always something new.
and hopefully some thought-provoking insights.
For everyone listening, thanks for joining us.
Until next time.